back, everyone, to the Wilson Forum on Science and Technology. AI may be perhaps best known to the public for the concern that it has generated over, for example, allowing fake videos, among other things. Uh, it becomes very difficult to determine what is real and what is fake in terms of some of those efforts. For example, I saw an interview of Abraham Lincoln last week. Now, that I could tell was not original. That was a fake. But when you see actresses like Tilly Norwood, who is an AI-derived actress, it's very difficult to tell when you watch her perform that she is not a human being or even a humanoid robot. So AI has some potential difficulties, but it is also being used constructively. For example, in science and engineering and medical research, it's become invaluable. Uh, Today, I'm really happy to add a new dimension to that list of topics where it can be extremely useful, and that is to welcome our speaker, Alain Briancon, who's going to talk with us about the application of AI to market research. So, Alain, welcome to the Wilson Forum. We're delighted to have you with us. Alternative program over to you.
Thank you very much, and appreciate the opportunity to talk about a topic dear to my heart, synthetic data, which is a very hot topic within the confine of marketing research. And so I organized the speech that way. There is more material on the slides than should be. It's a bad habit of mine. So I'm going to go through what I do, what synthetic data, what now, what are the reality. We're gonna go deep into the weeds at time, but it's necessary because if the expression is the devil is in the details, when looking at synthetic data and AI, there's lots of details, there's lots of devils. And the focus, which fits well into Ron's introduction, is that you need to find a way to qualify our good, thus our close. The synthetic data is to the real data, and that's an essential element of what my team and I practice every day. And I'll hope you'll get an understanding of why. A lot of the material is pulled up from work that we are doing in marketing research, but I try to bring some example from the rest of the world because any applications of AI in one specific domain can learn from other domains. And then when you thought that things were not complicated enough, AI synthetic data is now used to train AI systems. So we've gone full circle. So who I am, I've been around the block, maybe not as much as around the blocks as others on this call. I'm a serial inventor. A lot of my early work was in communication systems, and a lot of my later work has been in data systems. There are some unique parallels between the way you define a system that is where you have control planes and data planes, if you're used to this old terminology from the communication systems, with the data and metadata, which if you're in the data systems, you're aware of. I like to build systems. I don't like to build demos, which is, you're going to see that implications with some of the slides. And I love table that you will see there. There's lots of table in these presentations about it. Out of the 90 or so patents that I have, the one that I'm the most thrilled about is the one on basic geolocation. That was the subject of an interesting battle between Apple and Google. Google having acquired the patents from Motorola, where I used to work. So what I want to note is that I practice synthetic data carefully. With great power comes with great responsibility. That's a pre-Spider-Man or post-Spider-Man segment. So just as a background about who the company that I work for is. Dynata, you might have heard of, not is primary provider of first party data to the industry. The element to note is we conduct surveys, we analyze the survey, we generate results, and we have between 110 and 120 million completes, that is, answer to question per year. So we're producing a tremendous amount of data. It's expensive, it's timely, and there is a lot of push from our customers to start synthesizing the answers, which has led to these very careful evaluations of technology. So, what is synthetic data? Synthetic data is data that is artificially generated from other data that are real. And what you try to do is you try to mirror as best as you can the statistical and structural patterns of the real world data. And you're trying to do that while preserving the privacy of either the consumer who is answering the information or the company that is asking you to do that work. And that those definitions apply to just about any applications of synthetic data, with the likely exceptions of physics, chemistries, and the like, where you don't need to preserve the privacy of molecules when you try to figure how they folded. It is used in many industries, as you see in the bottom. What it allows you to do is to accelerate the speed, to a large degree, the speed of analysis and the quality of the analysis. It allows you to consider situations where you've got an imbalance in your data, or when the conditions are very, very rare, such as rare medical conditions or rare system conditions. So rather than trying to simulate how a Boeing might fall out of the sky because there's a problem in their turbine or the electrical system and the like, you basically create a digital twins, and then you you exercise that digital twins to make things happen. Same thing with medical conditions and the like. One of the important elements to note, if you're practicing data system, is that you could have a tremendous amount of dimensions that you have to take into account. It's especially true in market research when you've got demographic and psychometric information, location information, time information, and the like. So when you try to understand what a specific group of customers or consumers or businesses will do, you might have too many variables that you have to take into account. And what AI allows you to do, generative AI more precisely, is to fuzzy the analysis space, and you go from a very multidimensional, difficult to track system to one that is easier to manage if you are able to fuzzy it. Now, there are enough folks on this call to appreciate that, although it's not something that I use on a regular basis. To a certain degree, you try to apply the same principle that you have in thermodynamics, in the sense that a system has so many variables, so many elements, that the traditional equation-based approach at the cell level, at the atomic level, is no longer appropriate. And you try to basically look into a macro view, a fuzzy view of what the system is in order to do progress. So the revolution that is taking place is, in a lot of cases, you want to move from observing data to generating data. That's at the core of what synthetic data systems do. It's at the core a lot into why AI does, whether it's traditional machine learning when you try to predict results, or when you try to generate, a deep fake or the like. This is a generation process, and you try to predict how things will go. You try to augment them, and to a large degree, try to simulate reality. There are some unique practical constraints listed here. that drive this move to synthetics. Getting a lot of information from sensors can be expensive. Finding a medical condition that is rare is going to be difficult because you've got to wait for it. And in some cases, there are ethical issues with respect to waiting for conditions to have degraded enough for you to be able to pick it up. In the case of market research, it's expensive to find people that are willing to answer survey. And given the fact that people take 2, 3 surveys and then decide it's no longer for them, you're starting to run out of folks to do this. So access to high quality real world data is a challenge, and that's where things work through. Whether you observe data or you generate data, you have to be able to qualify its quality. And that's a multidimensional qualifications in order for you to use that data for the purpose that you have. And this is something that should not be lost. And I say should because it means it's being lost. If you are creating a movie, you want to make sure that um, the generation is correct. Just for fun, I used Nano Banana Pro recently to say generate a picture of me standing in front of the camera and then jumping on a horse and getting in the background. And 9 attempts in a row, my legs were going through the horse because the system didn't know how to take that into account. So that's a whimsical example, but there are some really life and death, very critical need to have quality standards. Um, when you are in the marketing research field, you need to provide results to your customer that are statistically significant for them to take the decisions they need to take. And if you don't have a way to qualify the quality of the synthesis or say, you know what, it's not going to work this time, then you are people making decisions on what is not a ground truth. Um, Do we even need synthetic data? Well, evidently, yes. Otherwise, we wouldn't be here. You've got, as I said, scarcity of data in all cases. You've got some privacy issues. Those barriers seems to be coming down, unfortunately, a lot. You've got operational bias. If you are sampling populations, or you are sampling a system, or you're creating a city simulator, smart city simulators, there's going to be areas where you don't have as much data. And if you're not compensating for this lack of data, then you will create systems that are inherently biased. You need to go for it. And last but not least, in many situations, you have the cold start problem. You try to examine a problem, you try to understand if the design of your system will work under these conditions, and you don't want to wait for those conditions to take place. So you have to simulate them. And for all of these cases, the synthetic world answers them. Um, an image is worth 1,000 words, or plus or minus 10%. I'm a data scientist, so I have to give a certain range, and you are through synthetic data able to cover areas that the real world doesn't. The thing to note, and from the get-go, is synthetic data creates realities. Richard Wagner famously said that imagination creates reality. So anything you generate does. And from this picture, if you can't figure out that I'm a huge Wagner fan, I don't know what else to tell you. And it creates a reality, and you have to take that as a grounding principle. Otherwise, you're going to lose the way to interpret and think about it. So now, having set the stage, there is value in doing the synthesis. There is a need now to make it work because there are some unmet market needs, science needs, engineering needs. I'm going to go into little details about the different types of synthesis method they are. This is the part of the presentations where the table are coming fast and furious. Of course, I will send the note to this presentation to Ron, who can then distribute to the people here. Um, if you look into an evolution, you can organize it using different taxonomies. So this is a taxonomy of synthetic method. It's mine. Different people will organize data either from an ontology point of view or to taxonomy point of view based on their needs. So this is not an official definition. This is the way I've been looking at this problem. So the first level, the lowest level of processing is you manage the ground truth. You make sure that your data is clean. You impute it when you can look at the average of values and it doesn't lose the element. But it is to a large degree a polishing of the data that you gather from the real world. You are measuring, you have a set of sensors and you're measuring them, let's say every 10 milliseconds, and there just happens to be a sensor that is acting flaky and only records every 50 milliseconds. Say, well, if there is enough relationship, correlation, predictive power score between the one that are sampling at 10 milliseconds and the one sampling at 50 milliseconds, then you can start to interpolate, impute the data from the missing sensor. The equivalent in the case of market research is you've got a survey with 300 people, 259 people answer all of those questions, and 41 individuals get tired of the surveys. They don't know when it finishes and drop in the middle. Well, if there is enough relationships between those who answered all the questions of the surveys and the one who didn't, then you can impute what those folks would have done. If you're doing conjoint analysis, when you're presenting different options about products to people, you don't project all the variations of the products and the services in the same manner to all the people taking the response. And so you're using methods to do this imputation, something called Bayesian borrowing. The next level of tier is traditional. It's kind of fun to have something that was heavy duties in the early 2000s and now referred to as traditional. My kids refer to Madonna as oldies. I mean, for crying out loud, I mean, that was oldies. I mean, what's next? Um, um, Predictive modeling and statistical learning. So the traditional again, that word of method is you have a series of inputs and then you try to create some outputs from there. It allows you to understand elements of cohesiveness, element of similarity, and the like. It is used in some form of synthetic data. And I take for this the broader definition I gave at the beginning, to is the transformation of real world data to other element. What is going on now is synthetic, generative synthesis, both in the text world, which is where I live most of the time, the audio world, the video and the world. You have systems that relies on approximating the underlying distributions of the training data. When you do that at the scale there is, the training data is text, massive amount of corpuses being used or corpi being used, and you are able to generate a text based on prompt. This is what most people have experiencing recently with respect to ChatGPT, Claude, Anthropic, and Gemini and the like. What happens is you've got this high dimensional space. Text is very high dimensional. There's a lot of structure. There's lots of information. And you've got the generative system that are able to compress these representations in the form of vectors. And then you're able to do this manipulation, and the generative AI is able to generate the text or the video or the audio that you've seen. What is now happening in this system is In before the tier one, tier two, and tier three, the human sets the objective functions and does the optimization of the processing to meet set objective functions within constraints that have been put in place. Agentic systems now, the policy itself and the objective functions are set at the macro level, and then the agents are interacting with one another in order to do the work. This is used a lot in workflow, and this is really the cutting edge where the systems are going. So at this point, your hands are off the wheel, so to speak, and the systems are learning on their own. If you've got complicated systems, when you try to optimize them from a workflow point of view or to understand the implications of a change in policy and the like, this is where this work is taking place. Same thing, my own taxonomy of data structures are table, unstructures are text, videos, and the like, transcripts, and the element. What to me is the most important, and this is my opinion, is structural information, where you've got things that links things with other things. Um, uh, you go on Facebook or you go on LinkedIn and you get recommendations or you get advertisement or you get info because the system has learned your structure compared to others. Um, my my wife's sister-in-law is into puzzle. I'm not into puzzle. I don't have any patience. We went to visit her in Boston. The system figured out on Facebook that I was in Boston, and now I'm getting advertisement to buy puzzle pieces. Evidently, the system has found the structure between the two of us and is trying to push me to go buy puzzle. I will not buy puzzles. Terribly sorry for your birthday. It's enough. Then there are physical phenomena and medical and biological phenomena, where here you've got the reality that has to be put in place, especially with physics. So it was earlier stating, quoting Wagner, that synthetic data as a form of generation and they create a reality. Well, in order for physical systems to make sense from a synthetic point of view, then you want to make sure that it obeys the laws of physics. For medical and biological system, then you have to make sure that the biological mechanisms that you have are correct. And what is very important is the clinical semantics of the text being generated or the analysis being done is correct. And I think that of all the fields, this is probably the one that is the trickiest because you've got a balance between privacy, utility, level of correctness, and the like, and a tremendous amount of regulation. So I did some work for a federal contractor in this area. It is very challenging. Because you're dealing also with medical conditions of humans and where the penalty for doing something wrong can be absolutely dramatic. So the balance of synthesis between your objective function, which might be to speed up the processes of claim, and the constraints, which is minimize the amount of errors, is quite dramatic. As I said, generative systems are extensively used. I'm not going to go through the table, but I want to highlight some of the elements that you see in bold. There are different techniques, and just going through theirs would take a couple of days, so we're not going to do that, even if there's a snowstorm coming on the East Coast. But the thing to note is Adidas is doing some pretty cool work with respect to generating what shoes ought to look like in order to meet marketing demands. And that's, to me, is a unique look into looking at GAN, generative adversarial networks, as a way to go back and forth. This is a system where you've got someone generating an image in this case, and then someone to spot if it's real or not. And this allows you to create some really interesting effect. This is how textures are being used in the Unreal system. And I find that to be, I would have not picked up Adidas to be on the forefront. Nike does a similar work as well. But I've not seen their slides, so can't really comment. Um, what's important also is you can use synthetic information to pass information that while preserving the privacy of where this information come from. This is different from using the hashing of an email or the protection of PII or PHI, personal information or personal health information. And it's a novel use of generative that has been used. Transformer, this is at the core. It's evolving somewhat. Mr. Kuhn is starting with one of the godfathers of AI, starting a business that says LLM are not the way to go, but the broad majority of LLM system, large language models, is based on this transformer architecture. And what is interesting, and this is something that can be used for marketing, is you are now able to synthesize complete databases that are self-consistent, both from numerical data or text, and that's being used extensively. That is also starting to be used for training of AI itself, which is something I'll touch toward the end. Um, the RAG, something that stands for Retrieval Augmented Generation, is when you take an LLM and you constrain it to extract information from a private corpus. And that's used a lot if you've got information in your database and you want a open text query rather than an SQL query to get the information. You've probably experienced RAG without knowing it when you're doing a lot of queries. Companies such as Bloomberg, for instance, take broad LLMs and then they adapt it, they tune it, and they apply it to the data that they have. And graph neural network is used in more recommending system than I care to list, so I'm not listing them. I don't know why I'm going backwards. I'm supposed to go forward. Okay. And I clicked too much, so my apology. Okay, so a quick view about for industries where synthetic data systems are used. It's used in insurance, where you want to understand what your policy is, you want to understand what fraud is, you want to share information from one group to the other. You've got regulations with respect to what can be shared. Um, And if you want to bring a technology suppliers or a business supplier or dataset supplier, you basically validate them with synthetic samples rather than give them access to real customers. That allows you to not have terms of services with respect to access to data. It also allows you to comply with regulations, and there is a series of techniques that are listed below. It's used more often than one would expect. Fraud detection is a key area. Similar techniques are used in banking. Healthcare allows you trying to understand are your tests are going to be working. Um, you simulate rare conditions. You have to be very careful about it. Some of the early synthetic of data from Watson were problematic because if you're training cancer detection based on generated image of cancer, you have to be darn right that you don't have biases and the like. It allows you to do mapping of how case might progress. One of the use that I like the most about this technology is to reduce the need to have placebo because you're able to do these early simulations. Now, in many cases, in healthcare and in marketing as well, which I'll touch in a second, you use synthetic data first to give you a direction of travel to give you a sense of what matters and what doesn't matter, to give you a sense of what you should explore. And then you go back to reality in order to explain it further. So, um, synthetic data system can replace in some cases, few cases, but typically augment the data or augment the flow by allowing you to pinpoint where your expensive research, your expensive design, or your expensive analysis needs to take place. In manufacturing, you look into conditions for predictive maintenance in order to train your robot to know what is supposed to go up versus down and what have you. You can use synthetic data, and you are able to do a lot of what if scenarios with not having the physical plan be put in place. Um, One of the most challenging area is generative AI, where you have to impose physics. There are very few AI systems where no guardrails are present, and this is one evidently where they need to take place. This is quite challenging. Every 6 months also, I see a video from Boston Robotics, and I was like, wow, this is the outer range of what could be done. And then you just wait 6 months and says, oh, okay, so this is the outer range of what can be done. And then after a while it says, well, I'll wait 6 months to see if there is a range. And this is where you've got these generative AI approaches to multi-sensor extractions and the physics-based implementation that are mind-boggling. I saw the last one last month, so I'll wait until June. Retail, it's starting to come a little closer to market research. Um, you synthesize customers to understand how to segment things, and you use them as a way to understand what kind of recommendation you should take. One of the naughtiest element that I've seen are pricing strategy that you understand through synthetic demand data and synthetic respondent. Call me old-fashioned. After all, I don't think that Madonna is an oldies, although she hasn't done anything recently. But I'd like labels at the store to be on paper. Thank you very much, not an e-ink display. It kind of inherently makes me a little nervous. I think we are all aware that if you go shop for things on airline and the like, run your browser on one PC with a VPN, run your browser without the VPN, and go to the same sites, and all on behold, under the same product, you will have different pricing. I hate that to happen with milk and the like, but there is a lot of optimization of what to sell and what to position, and synthetic data is used very extensively. So on to home, at least my home for a while. Market research. What we have a lot, this is an example that it's the bread and butter of request on synthetic data systems we have right now is I have an audience difficult to reach, and I need to augment this audience. I use the example of oncologists in Ohio. I reach a certain age where the word oncologist is almost pseudo-natural. And I want to know how much they are willing to prescribe the new lifeguard system versus the full gamut. And we don't have a lot of it's difficult to go find all those oncologists in Ohio willing to answer the questions about what they're doing. But we have a lot of people in Ohio. We have a lot of doctors in Ohio, and we have a lot of frequent flyers in Ohio. We have a lot of people with, income or, places where doctors should go. Well, we could sample a broader populations, and then from that population, we try to boost the number of people that are oncologists in Ohio so that we can derive what they would do, what they would buy, what they would consider, what they would recommend. So you've got a broad populations and you've got a narrow populations. And the art of the deal, and you'll see some of them have later on, the art of the deal is how to find out there's enough relationship between this broad population in green and the population in the triangle to boost the number of people you have in the triangle so you can better understand how to market products or what their behaviors will do and the like. This framework can be duplicated in the biological world when you've got, let's say, elements that have that has a certain pathology and other elements that have specialized pathology, and you try to understand what's happening more in the specialized pathology. This is there is an assumption that you can synthesize everything and every population. Actually, at customer have asked me, can you create a synthetic view of the U.S. population, 360 million more or less? And I was like, and where do we think do we get the data? I mean, we would have to sample 360 million, so it's somewhat of a non-starter. So you can negotiate the number down, and then you go into the areas of segments and the like. But there's a lot of interest to understand how to reach harder to reach a community from a business point of view, from a consumer point of view, because as you try to extend your market or your market share, those folks that have not been reached out so far are typically the one that you've been able to reach so far are the one that are easier to get, not the other way around. Believe it or not, but please believe it, is from a survey point of view, the general population 18 to 24, and you would think that that would be easy to get them, but not always easy to get them. They like Instagram, they like TikTok. Not blaming anyone. To take them to take survey can be challenging. The people that are more consistent in taking surveys are old guys. So I feel good that I am in the preferred segment, even though personally I rarely take surveys because I'm working on doing the math behind surveys. So the way we've positioned market research, three things. In our case, the bottom category is we are missing answers or we're missing people, so we're going to try to find people and we're going to try to find answers. And yes, I do use the word equity. I'm probably at 0.5% of the population that still dares putting it on the slide. And the reason is because if you want to reach a minority population, which could be from an ethnic background point of view or from a professional point of view and what have you, it matters to you that they are represented. So this is to me truly an equity element. So in our case, it could be that you fill in the unanswered questions or you augment the population. The next one, which is a little more specialized, is you have survey instruments, the way you organize the surveys. And if you know what surveys will work and what surveys will not work, then you are able to do a better job when things take place. So let's say that you've got 10 products that you like to test. Test 10 new variations of a cola. Lemon lime, and lemon cherry, all kind of combination that you can think about. What it would be nice to reduce the number of variations you're going to give to real respondent, to human respondent, so that they don't spend 40 minutes answering the surveys and likely quitting. They only spend 15 minutes. So this is going into a core mechanics of what we do in the market research industry, and it's one that has once you start having discussion with customer, a lot of interest. A lot of folks want to complete the data and to make sure that all groups that are hard to reach are captured and expand the data. But when you start looking at what about making sure that your traditional business of creating a survey is getting the answer is more efficient, it's like, oh, that could be an interesting use of synthetic data. One that our industry is getting a lot of play is synthesizing twins. You have enough data, behavioral, attitudinal, and the like, to query that system. So rather than querying an individual, you first query an individual, you load the data into a system, information from those individuals as well as supplementary information, and then you query that system. This requires a lot of very high quality data. This requires a lot of very high quality um, AI techniques. It's at the forefront of where a lot of market research agencies and big corporations want to go. And this is really a point of confluence between data and methods. As I said before, agents are changing everything, so I'll skip through that one. The takeaway is agents are changing the game. That's the title of the slide, so you don't even need to look at the table. So, a lot of data, lots of methods. What do we know? Things will go wrong. It's simply too darn complicated. It's new, it's a system and the like. So, bad data, bad outcome. Bias will happen. Hallucinations will happen. Mislabeling will happen. Systems that are great for a demo will break down as soon as you change a few conditions. And then at times you try to do something and it simply does not work. And I'm not, trying to rain on anyone's parade. This is what the evolutions of all the technology is. And this is the angle that you need to have to make sure things work well. Why? Because as with any new of technology, we're going to go through a hype cycle. And where I think quality is playing is after we go through the drought of disillusionment to make sure that the data is actually used. I think that in some use cases of SDS quality, especially for marketing, we are in the, going up toward the peak of inflated expectation and it's going down. On the first line, I've got a disclaimer that this is my position, not Dynata. This is the one slide I want to make sure for the record. It's my perspective on where we are. Other people think, we already are very productive. This is the view to me for SDS quality, especially in the marketing world. So what do we need to do? We need to handle the truth. We need to make sure, that's an oldie movie, by the way. That's what I've learned as well. You can tell it's old because Tom Cruise looks so young. We have to be able to, for each one of the type of data that we have, to make sure that the results are what they need they need to be good results. Different types of data have different level of the truth. You see them listed. If it's physical, it has to be physical consistency. If it's structural, there has to be causal facility. And if it's structure and unstructure, the statistics have to make the sense and the language have to make the sense. When looking into how it's being instantiated, there is a emerging trinity of quality that the industry is moving into. It's a triangle, so I can represent it as a triangle. So there's the fidelity component, which does the data looks like the real data? And the important question is, to what degree? How many significant digits do you really need? Is this deviation in this case because it's impossible, you don't have enough data to do it, okay or not? You've got the utility. Is it functionally equivalent and is it useful? If you use synthetic data to decide to build a plant in Frankfurt, Germany, to produce toothpaste, that's a different level of utility, pragmatism, anxiety that you try to figure out, do I change the labeling of my toothpaste? I'm taking a really silly example, I know, of my toothpaste going from ounces to milliliters. You can use synthetic data to do either. In one cases, it's useful. In other cases, it's not good there. Last one is make sure that you've got that the data is private. And different fields have different levels of privacy. Physics doesn't have terms of services. When you get information, primary information from customers, it does. When you look into the fidelity, which was at the top, there are some soft and hard boundaries. You've got things that you'd like to have and things that you must have. Again, as I said earlier on, is like table and um, you know, can read after this call, but is what you have to be careful is there are some hard boundaries. And what does it mean? It means that whatever AI technique you have must be followed by guardrails. Any system on AI that doesn't have guardrails is asking for trouble. That's really my perspective. And we just have to look into the Zoom valuations after they use their generative AI in order to decide which houses to buy or not, to realize that guardrails are probably a good thing, even when you're doing pricing and the like. If you're using dynamic pricing, but you can use for airlines, I'm pretty sure they've got guardrails, even though they can try to optimize what they can get from you based on your previous browsing history and your previous travel history. So the takeaway from this slide is there are boundaries. We produce we are producing synthetic data systems, and what was the triangle before, you have to make sure that when you're doing market research is a little broader. So here we go, it's a net. The fidelity, you have to make sure that you've got not only analytical accuracy, but you have to make sure that you have representativity across your system. When looking at the utility, you've got the economic impact and the operational tolerance that your company has. What an aggressive first mover company is willing to deal with compared to a fast follower, compared to a middle of the road, might be different. It might be the same economic impact, but that company might have different threshold with respect to accepting results or not. You have to take that into account. Privacy is privacy. The thing which is in blue is for us, and this goes to at least my biases of doing system rather than demos, is you have to make sure that if you synthesize data for customer A, you can use the exact same method to synthesize data for customer B. Otherwise, it's a one-off, it doesn't scale. You need a lot of data scientists, a lot of AI engineers, a lot of people doing data engineering and MLOps, and that's not a way to grow the business. So this is an additional threshold that we have to put on top of our system. A couple examples, sorry for the special effect, I didn't remove them. When you look into fidelity and consistency, you could say, well, I've got an original image and I'm going to ask people what they think of it, and then I'm going to average it out. It's something I picked up from Reddit. Let's give credit where credit is due. And at the end, you're like, okay, I got an average view of how different customers represented the Mona Lisa. And if you just take the average, then first moment doesn't tell me anything. Again, sorry for the special effect. This is an interesting little thing that we've discovered we discovered when we started looking into boosting. This is in the weeds for market research, but I want to share it. So you're doing a survey, you're asking people a bunch of questions, and then someone comes to you and say, "Oh, I want to boost the population." I was like, okay, I can boost the population. So we go from the orange to the purple. And then you ask them the questions, what do you want to do with it? And so the same mathematical operation, the same mathematical logic, guardrail, and so on, you look at it. And in some cases, yeah, your synthetic population can be used for your purpose. In this case, understanding purchases. But if you try to understand if you can reach the customer through mobile applications or through emails, then it doesn't work. And right there, shows that the utility, which goes after the purpose that you're trying to do, is a dimension that you have to take into account. It makes the selling proposition in our field more complicated, but more appropriate to the problem at hand. We have lots of measurements. I stated early on that we want to have quantitative measurements that you can create. So it looks okay to me That's great when you have a Teams meeting within the company. But if you want to sell the results to someone, or if you want to productize them, or if you want to make them as part of the workflow, then you need something, you need a number that you can relate to. And there are different measures of fidelity. These are some the one we're using for market research. Tons of other methods are used in different fields. Same thing on privacy. There are standards on privacy that can be applied. Um, the distance between synthetic record, let's say that you have a digital twins that answers questions on behalf of someone. Could you, if you were to have exact digital twin of a specific individual, could you reverse engineer who these people are? I think it's a pretty known fact that if you got the first 3 digits of social security number and your zip code, then you can start narrowing down who the person might be. In Canada and the UK, when you've got these 2 blocks of zip code, the first 3 character and last 3 characters, if you start having some information with all six characters, then you can start to reverse engineer and figure out who the individuals are. So there are measures of privacy that you can have that can be applied to your result. So we have different uses of synthetic data. We have different criteria for it, and we have different measures that allow you to qualify and quantify whether what you have is good from a privacy point of view, is good from a utility point of view, and is good from a fidelity point of view. So it says, oh, that's simple. We just put all of them together and do the computation. And the answer is now we have a curse of dimensionality in the measurements metrics that we have. So if you like to do all these measures of computations and the like, you're going to get a bunch of digits. But if I go talk to a customer or any human being about, this is the natural language inference and the linkability score that you have, and this is the pairwise correlation difference of the data that you've got, you're going to get, what the heck are you talking about? It was bad enough to have to deal with all these synthetic data, the pros and cons. The physical, the quantitative representations of the system you have becomes a challenge. Right now, this is in the work that we're doing with my team. This is where we are. We're trying to distill what makes the most sense. Customers in marketing research are used to levels of significance, lift, power score, p-value, and t-students, one-sided and two-sided answer. That's their data science level of understanding things. When you're looking into synthetic data, we need to find a way to take those measurements and bridge the gap of quality with them. We have a system when people take real survey, we're using AI to reject those that we think are bots or lazy and the like. So, and the customer can reject a certain percentage of answers. We happen to be best in class in the industry. Not happens, we work hard to be at it. But when you're looking into synthetic data, now you have a new language that has to come about. And that's quite challenging. But our position is without quality metrics and metrics, you get results and you won't know if you can use them or not. It's one thing to do generative AI pictures and audio and the like, but when using that in a business context or in an engineering context, those elements are going to be critical. I think that what's happening in smart city simulations and what happening in physical system and in workflow will guide what happens in our world, the world of market research. Last, and possibly least, not sure that last, is synthetic data systems now are used to train AI because you need more data. One interesting element is if you look into how people are making decisions, you're not going to get folks, I think that's an interesting use. You're not going to get folks says, I'm doing this and that and this and that and that. There's a lot of decision we do by instinct. We take irrational decisions often. Um, um, and at times we in tune where things should be going. Having a synthetic data system that develops, step-by-step approaches and the like, allows the AI to not look into the original point, the problem statement, and the end to kind of learn what's going on. I personally find absolutely fascinating, even though I understand 0.1%, is how these LLMs are solving these very difficult mathematical problems. And there are obviously people on this call who are way smarter than me to understand that. But I find one fascinating is to understand what the logic is. I've used large language models, generative AI, to solve some simple operation research type problems. And every now and then they go on a path that we have never gone on my own, which means I have to go back on paper, back on Excel, back on Python, and try to understand is what they're talking about makes sense or not. Um, there is in this case, there is a lot there's the beginning, lot, I shouldn't say that. There's the beginning of looking into the verifying quality. This is where the human in the loop, HIL, becomes very important. And it's interesting to us, and it's good for us that you simulating um, uh, uh, respondent or twins, but the ground truth happens to be, at the end of the day, the human. And right there also, there are some interesting problems because since we're not rational and we don't always make the same decision at the same time, is the ground truth of a human the ground truth? I forget the gentleman who says looking into the future, where we are going into, humanity, its evolutions and the like. Even the definition of ground truth becomes ground truth. If my synthetic twin were to be better than I am, isn't it better to deal with it than with me? I don't know. If you do, I just like a residual. That's all. What do I want? I want my residual. When do I want them? I want them then. There is some obvious implications of machine feeding machines, AI feeding AI and the like. And the big one, sorry for the collapse that's going on the left side here, is the model collapses. You learn and learn, you go to the weak law of large review or the weak law of large numbers, either one of those, and the reality becomes a caricature. The other risk is people stop trusting it. I, for one, as I get a little older, hopefully wiser, now we're going to get AI to decide what operations are allowed under Medicare and the like. Okay, well, do I trust it inherently or not? There was discussion, early introduction about the interrelationship between technology and government. Well, this is one of them. The solution to those things, in my mind, are this three-step process. You simulate, you reassure, if you can, you validate, and then you iterate. And you have to put that things in place to make sure things work or not. And of course, we have the issues with any kind of new technology or not to regulate or not regulate. Um, and that is the question that's one of many questions. A long presentation with a lot of material. I'll be the first one to admit it. Um, Final takeaways of the takeaways of the takeaways is synthetic data is a version of reality. It's not a replacement. You can use it to append, augment, verify, do counterfactual analysis, but it's not reality. And testing reality is hard, but there is no replacement for testing synthetic data. Testing reality in this day and age becomes something I've got to do every morning when I look at my news, but I digress. Testing synthetic data is hard, but I don't think there is any replacement about it. So I don't know where I clipped this from. I think it comes from Cornell, and I absolutely love this. Whoever put this stuff together, we do this not because it's easy. I'm not going to do my Kennedy impression, but because we thought it would be easy. With that, I want to thank you all for letting me go through something I feel passionate about. Um, and work email, non-work email, and LinkedIn. And or if after this call or people that are watching the recordings want to ask questions, then they know how to get a hold of me. This is a pre-mustache cartoon. I will get back to it as soon as my wife tells me I'm tired of the mustache. So FYI. With this opening now for
Great,
a
great,
question and
great.
feedback. Thank you.
Alain, thank you so much for that presentation. Let's do one thing first. Let's stop the screen share so we can get everybody on screen.
Yeah,
And I have a couple of observations. I know there are going to be lots of comments and questions.
sure.
My first observation is you mentioned your scientific twin might be better. But my question is, does it drink beer? Because if it doesn't, I don't want to deal with it. Just personally, that's my preference.
Um, okay. I'm a wine snob, so I will pass I will pass. Yeah.
Okay.
But this,
No,
but this is to me a serious question, and it goes into the randomness of things. Um, Large language, an example, we're doing some work with a Harvard researcher,
yeah,
and you could ask a large language model, do you want to buy this product? Yes, no, blah, blah, blah. How
yeah.
much are you willing to pay for it? $130.4. Question, what was the GDP of Zaire in 1962? Here
Yeah,
comes a number. I lose track of Zaire, Congo, and all that things, whether it was there in 1962. So bear with me.
yeah,
This is not something that I should know. I mean,
yeah.
unless I'm looking at Wikipedia at that very moment in time. So there has to be the uniqueness about humanity and the like. I don't mean to be too philosophical, is to me an important element. Someone which is too deterministic with respect to, sorry for the clicks, but it's too deterministic, might be good in certain cases, but bad in other cases. So on the beer side, I'll be neutral.
I should have chosen wine. I get the point. Look, I do want to thank you though. That was not just an informative and illuminating talk, but frankly, it was reassuring. I think we all have some awareness of synthetic data, but there's a certain amount of mystery among most of us, I would say. And let me give you a concrete example. I'm a material scientist by training, by education. I have some experience with computational material science and engineering. It's probably best manifest in what is known as the Materials Genome Initiative. This is an initiative which has as a goal speeding up the development of new materials and at lower cost
Yeah.
so that they meet advanced engineering system requirements. For example, materials for hypersonic vehicles, semiconductor photoelectrodes to split water for hydrogen production, etc.
Mhm.
Now, we're beginning to use synthetic data, but we have as a sort of a safety net, NIST, National Institute of Standards, and
Yes.
they're our curator. They validate data. They make sure it's acceptable data, that's authentic, that they're concerned about fidelity. They're concerned about personal security. All of the things you mentioned are, in a way, are integrated into this effort on behalf of the materials science and
Yeah.
engineering community. But that is also true in many other, in terms of science research, in terms of medical research, as you
Yeah.
pointed out. My question is, with the materials effort, NIST provides a resource.
Yeah.
And I'm wondering, when you talk about ground truth in terms of the work you are doing and you mentioned, is there an equivalent, anything like NIST for synthetic data? Anything emerging that would provide that safety net, if that's the right word?
Um, this is a fantastic question, and I smile because my wife was a serial entrepreneur, and we were at a presentation one day, and how to pitch
Yeah.
how to pitch companies, and someone
Yeah.
says, what is typically missing, and in a presentation, and then one guy says, the slide that the guy before told you not to put in. And it just happens that the slide that I took out was where the standards are. Um, very strong believer in standards, and that's the reason so much work we are putting and I'm putting into this. There are performance metrics and the like, um, and but there is no standard body for market research or for data and the like.
Okay.
What I'm trying to do, and part of the reason I'm here today and going to many conferences and like, is say we need to establish it. The
Yeah.
challenge is that it's very hard because of the dimensionality and the interaction between purpose and the like. The regulate versus don't regulate I think comes into it. AI, my theory of the case is 80% data, 20% complaining about data.
Yeah.
The
Yeah.
algorithm themselves, GPUs, TPU, SPU, whatever, are deterministic. Forget the LLM for a moment. That is a certain element because of the way we're learning. So if we move to quantifiable standards, we will move toward having these elements. The challenge, in my opinion, is that it is very context dependent.
Yeah.
Within the marketing world, this is a key thrust
Yeah.
that we are pushing forth. The challenge we have is because there is so much hype that's being dismissed. Don't worry about it. The challenge the comeback that I use in there is the day you make the wrong decision based on this, the reckoning if you don't have standards will be great. So I think there is an association called ISOMAR that sets broad frameworks and the like.
Yeah.
There is no this is gold level, this is green level and the like. And I think you saw the diagram with like the three
Yeah.
ellipses and all the points. It's difficult to get, but
Yeah.
I think there needs to be the equivalent of I can use it for that purpose, whether the government jumps into it or not. If there's battles on not regulating AI, you better believe that there's going to be battles on non-regulated synthetic data. There's going to be some blowback. We just have to look into Grok that decides that nude pictures of kids is okay. So it says, okay, the problem is how do I write this at the data level, not at the output level? At the output level, it's okay to get a guardrail. At the data level, it's a little more intricate. But we have to do this because it needs to be done in order to make sure that there is trust, first
Sure.
by
Yeah.
company that are using it and ultimately by the public.
Yeah. I agree. Thank you very much for that answer.
You're welcome.
We have a number of hands up, so let's go first to Jenny.
Okay. One question about agent, the other about the V and the V, verification and the validation. On the agent, you mentioned agent is changing the game. Could you give us an illustration and some of the nuances in terms of a data synthesis, the role of the agent is playing in data synthesis? The other question about validation, verification and validation in generating data and also in using synthetic data. And with your extensive hands-on experience in synthetic data, can you give us, I think you alluded in your presentation, but I just like to a little more of a concise of some of the tips and recommendations in the process of V and V.
Okay. Okay, let me go through the easy one first, which is the agent. Well, no. When you're doing an optimization if you have a constraint optimization and you have multiple dimensions into your constraints, and some of them are hard and some of them are soft. Finding a way to find the best policy or the best balance of attributes and the like is inherently an NP, for sure, a very complicated computational element. So where agents are used, is to say, you're going to get multiple agents dealing with one another. There's an orchestration system. You're going to get one that enforces the hard limit, as a certain weight that is associated with the soft limit, another one that computes an objective functions, another one that figure out what data to generate more in order for these first two agents to work. And so what this allows, where the synthetic data that uses that context is the one that allows you to explore your search space, your guardrail space, the best in order to have the right balance between a soft constraints and a and your objective function. We are beyond the point of using Lagrangian multipliers, going really ancient time, to figure out how to do this balancing. So these systems are interacting with one another, where I've seen the synthetic data being used is to understand if there are different conditions with respect to the system that you're trying to go at hand is pushing the envelope on the soft constraints versus pushing the envelope on the objectivistic place. We're not using agent there, but an example that comes to mind is if you're trying to do an allocation problem. We're not using it in that context, but if you're using, let's say, an allocation problems with respect to airline optimizations and try to understand what your policy are, then you have an agent that simulates the plane arrival, your schedules and the like. You've got the amount of time at the gates and all these different elements, and one that deals with the mix of traffic of passengers that you want to go through, some that you can bump, some that you cannot bump through. So you can have agents that trying to solve this problem, and then you synthesize the system close to the orchestrator will synthesize different conditions in order for you to explore as much as possible. The second question, which is the insight for validation and verification. I don't know enough about what's happening in material science and physics. Try to get a sense with respect to the airline, because allocation of resources for airline and supply chain management is very similar to what we have to experience and what our customers have to experience. For the moment, I think it is a series of simple metrics, and you force yourself to test them. The method from machine learning, which was in the tier 2 in the slide that had the different tiers, when you've got a training set, a validation set, and a testing set, I think are the right level to understand the sensitivity of your synthetic mechanism to variations in the assumptions. Because AI has become so powerful, there can be a very close relationship between the synthetic system and the original data. And you would say, well, that's great, because that's what you want. The challenge is, if you change the original data, people travel more than Thanksgiving, and then followed by Christmas, maybe Easter, than the rest. Then you might have synthetic systems that are too linked to those elements. So the traditional framework of, if you can, of training, validating, and testing holds, and then you apply those metrics. There is no, I don't have any, I should be careful. I don't know of any simple answer to your element, because where we are now is the diagram where you see the man with the beard in the center. Good Lord, Alain. Not enough coffee yet. Only 1 liter so far. And the different variables is the way to synthesize them is difficult. You don't want to go, what is the value of the engine check light in your car? It tells you there's something wrong. Go do something. The angel, we need to go to the angel warning light concepts, or 2 or 3 variables and the like, and test it. The challenge you have is this, whether you take the simple trinity of value, fidelity, privacy, utility, or something a little more adapted to our world, which was the heptagon, sorry. You need to you need to simplify the output so people feel comfortable. And I will venture, well, I'm not going to venture, I'm going to say, I think in many cases, the qualification of the quality of the synthetic data is more difficult than the synthetic data itself. There was a famous saying, I don't know who is the Supreme Court justice would say, so it says, I don't know how to define pornography, but I know it when I see it. You you cannot build system on synthetic data when you say, I don't know this is good quality, but I'll know it when I say it. You need to have metrics. The art of the deal is to reduce it to things that are useful and the like, and that can only take place when you have dialogue. One of the early discovery that we did on something as simple, it's not simple, but it's on the simple side of things, which is boosting, is the purpose of the boosting impact whether you use it or not. And then you go, oh, darn, this is really going to be complicated. It's like, yeah. And it's complicated, the customer gets confused, and we know that a confused customer doesn't purchase.
All right. Look,
Thank you.
Welcome.
thank you very much. We have three hands, and I'm always sensitive to the time because I know people have schedules to keep.
Yeah.
Let's see if we can get through these as quickly as possible.
Sure.
But Eddie, go ahead.
Yes, I'll try and be brief. But basically, um, I think you sort of indicated in your talk about the equivalency of systems, the ability to identify a problem related to another problem. In physics, we see that a lot.
Yes.
Quantum information theory is, strangely enough, now incorporated into a model or theory of gravity.
Yeah.
And so I guess what my question is, it goes along through all this whole thing about validation and so forth, is the ability to find data that already exists or systems that already exist, to which you can make a comparison and have more confidence in what you're trying to do.
Yeah.
I don't know if there'll ever be a way in which you can create a system upon a system, in a sense, that enables you to choose the kinds of systems that are related to the thing you're trying to do. So maybe that's a kind of convoluted thing, but I felt that you were trying to hint at that or discuss that in your talk.
I think it's a great and I mean this very positively philosophical questions is at when you're looking into the reality what synthetic system does and how it augments other systems is at one moment there's to be kind of a closed loop. We're saying that now, but using human validators to make sure that the digital twins are okay.
Right.
And by the way, the human validators are the data scientists, and at this point, and the MRI research analyst that looks at it and says that stuff makes no sense. I mean, for crying out loud, we're not going to get these people to buy this. I don't care. Or why are you telling me that these people are buying diapers when they say they don't have kids? Very basic Q&A. That would deal. But at one moment or another, there have to be those systems taking place. I think that when you're looking into data systems being used to train AI training AI, this is where it's going to hit things. And this is why I wanted to bring up the fact that you've got some soft barrier and some hard barriers. And, but how it goes in evolved is going to be very context dependent, very industry dependent, but it's going to be fascinating to watch.
Thank you. Thank you for that.
Good question. Thank you.
Marv, let's go to Marv. You're muted.
You're muted, Marv.
There you go.
So I have about 1,000 questions, none of which were generated by AI. But I'll narrow it down to two. One somewhat short-term oriented and the other longer-term oriented. The short-term one is, first of all, I really do appreciate the focus that you and Donata have on validation of information of understanding it in the context of a superimposition on reality, but not reality.
Thank you.
I also recognize that's not the common way in which this is being approached in the broader spectrum. And so, just talking of market research, and this is the first question, is an area I spent a lot of time in. The line between understanding and manipulation is a very thin one. I worry a lot about implications. So the first question I've got is, what are your concerns about the manipulation from this deep understanding? And the deep understanding can be, de-identified or de-non-identified data, which can triangulate somebody and identify them. We've been doing that for 30 years. But it could also just be a group where you're able to influence a larger group who has certain behavioral characteristics. So that's the first question, and how you see that evolving and the concerns from it. The second question is really that the evolution, in particular, the last 10 years, and I was at IBM when Watson was being built, and was fully aware of it. So what we've had for the last 10 years in particular, but it's gone back further, are essentially Lego pieces, evolutions of pieces of different technologies, whether it be GANs and video generation or whatever it might be, that then get snapped together. And we've seen that in the public front page for the last 2.5 years, 3 years, I should say, with, something that started out just talking to you, and then it started reasoning, and then started video generating, these constant assessments. But there is a strong sense, among many people, I think Gary Marcus, who's not always my favorite commentator, was one of the first to talk about the limits of LLMs. And people like Fei-Fei Li, Jan LeCun recently, and what surprised me last week was Demis Hassabis, who, for those of you who don't know, he was the founder of DeepMind. There were a number that was acquired by Google. He won the Nobel Prize for AlphaFold, and he's the head of AI at Google. And for the first time last week in a CNN interview, he basically said LLMs are the end. They're not. They're more like the brainstem, functionally. They give you some basic function, almost instinctual ability of a frozen nature, like an instinct. But now we're moving into, theoretically, and this is where everybody is going, to world models, which are systems where you don't have frozen data that you've trained something on, necessarily even synthetic frozen data that's in continual transformation as it learns spatially in the environment from a lot of different types of feeds, some of which we might not understand. So as an example, just to give a sense of that, we are limited in what we experience on the electromagnetic spectrum. It's 0.0035%. It's a very small amount. But we experience something like light, that small section of the EM, as a full-time, real, current, transitional, continuous experience. AI has not been trained on that type of experience, but world models will be. And so understanding both, not just what it's learning and validating what is information in transition from multiple sources, it may actually receive as real-time data and perceive it, process it, data we can't perceive, like information outside of that amount of the electronic spectrum. So what are your concerns about that long term? How do you see world models playing into the type of work you're doing?
Let me try to answer the second question. Then let's go on the first one. And now we're in the stage of pure opinion. I'm not smart enough even to point there. I think world models are likely a new foundations of when you want to go forward. And I think the dynamic learning in one way, shape, or form will play a role. I might have the age a little wrong, suppose for that. Someone made the the computations of the amount of bits of information, and let's not go into the exact definition of entropy that we use for that framework. I'm a huge fan of entropy. I said that in one of the slides. Of all the text that has been generated so far, that would be the basis of LLM, and compare that to the amount of information that either it's a 3-year-old or 5-year-old has experienced through listening and looking into from 0.5 micrometer to zero point 0.8 or 4 to 8. I'm too old, I don't remember which micrometer visible light is. And you just look at this and it's like, okay, well, there's innately limitations. And you said, well, video is going to be richer and so on. Well, there's so many movies you can produce. I mean, Netflix is pushing the envelope, but that's another story. So I think that the learning system, learning and adapting based on a dynamic framework are likely going to be kind of the next generation. How does this instantiate and kind of get the element? This is where the augmented reality, my reality, and the like becomes, I think, very difficult to wonder. I'm old enough, I'm not going to worry too much because that might happen after, I'm gone. I think it brings some really difficult issues to resolve, which is, lineage of data and usage rights and the like. But the LLMs are going to go through an upper bound of capabilities. We already have the stage where utilized applications, first using RAG, now using LoRa Twin LLM, now going to SLM, are used to solve problems with a better accuracy. And I use the word accuracy in the English sense of the word, not in the statistical sense of the word. So we are already bumping ourselves against the limits that are taking place. There is one thing that I think this evolution is showing. I use these percentages to say data. AI is 80% data and 20% complaining about data. I think the interrelationships between AI, data and AI is going to get more and more blurred. You can, on traditional systems, so you've got the raw data, you clean it, you curate it, then you transform it, then you train and you validate, and then you test and you learn, and then you put a guardrail, and then you output it. And I've got beautiful diagrams with multiple colors, and multiple people have multiple diagrams with multiple colors. That thing becomes a mush. There was an early discussion, and I use this expression about we're trying to reduce things by going, when you have such high dimensionality in the world we have now, we try to go to a thermodynamic principle, which I mean is we take an abstracted view. We don't need to have an Avogadro number worth of respondent in order to get there, but that's a way for us to kind of deal with fuzzy. My gut feel is there's going to be some light transformation about the way we represent data and we represent processing of data that has to emerge, because the interconnection between the original data and the AI and what has been created and the learning, I don't think we have the vocabulary for it. And I don't think that the traditional framework of raw data transformations, modeling, which creates a new piece of data, and then guardrails will hold. It's already kind of breaking for LLM. But the LLMs are using however big, a very finite use of information. So it's going to be fun to watch.
Yeah.
So can I ask a follow-up question on that? And that is, do you view the work that you're doing right now in a sense transitory? Because it is sort of based on this idea that the source of the data is definable.
Transitory, if it's long enough, looks almost stationary. We can go into I think it has a finite life. I think what will change in the marketing world is that the value chain will be shaken enough by this transformation, and that's the first thing that's going to change. The traditional, I collect data, I put the data, I run a report, I make decisions on it and what have you, that thing is going to get compressed. I did this interview on which got posted on LinkedIn about what's the destination for AI, and so the destination for AI is speed, which a friend of mine sent me an email, says speed is a scalar. You should say it's a vector. Says I've got other things to do than to go to heavy math. So right now, I think what will happen is the access to knowledge needed to make a decision is going to shrink. I don't Google anymore at Gemini. And then I've got to deal, how many pages do I need to delete to go back to the stuff I had? So I think that has to take place over and over again. And then I think a later transformation will take place. We adopted to the death of distance. This is what cell phone technology has done. I think we're going now to the death of time with respect to access to the element. And I don't know what the next thing will be, but I think we have to understand that. So is it is this transition in nature? Inherently life is, inherently those systems are. How does it evolve later on? I don't know.
Yeah.
Okay, and I think I have time for one more question because I'm sure my staff is going on. Where are you? But they're always giving this discussion. So
We have one more hand up. Do you have time for one more, Alain?
one more head up, and Nancy would have to be patient.
Yeah, no,
Sorry, Nancy, if you're watching this later on.
Go ahead, Albert. I hope it's a short question.
Well, Alain, very nice presentation.
Thank you.
I have a question and then a comment. The question is, I have intuitively avoided social media completely, and I'm bombarded with surveys, and I'm extremely selective as to which one I answer. So I don't provide any of the data that you talk about using. My question to you is, how representative am I of, let's say, the US population? Do you have a sense for that?
Oh, how do I say that without getting in trouble with your significant other? You're not. You are unique.
Can you put a percentage? How many is it? 0.1%? 1%?
1/360 million, whatever that is. It's a difficult question to answer because I need to understand the attributes that you define as unique and you define as a representative. And this is why surveys are used, and I appreciate if it's on Dyneta hosted that you take some of them. This is where, in order to make decision, in some cases you need 300 people, in other cases you need 2,500 people, and you need to balance it against specific demographic and psychometrics. So it's almost how long of a rope do you have? You know, how representative you have. There are some elements that are going to be very representative and others that are not. But what we have found is for the current use of technology and the like, you need 300 or so people to get something representative. There are some companies doing pure synthesis of population, based on data that were collected by, the Axioms of the world and other people that have been collecting data over the years. What you'd be not surprised is if we have limited information about you and it's augmented, compiled, or extractable with data from others, then there's an interrelationship between the way you behave, the way you live, and the like with others. And the information from them can be found a way to impute it. And I use impute in the non-mathematical definition, can be imputed to you. So we are different, but we are similar. The art of making this work is to understand the interrelationship between the similarity you have and the uniqueness and how random things are. One of the paradigm that I use is information theory, not because I went to school at MIT, and not because Claude Shannon was at MIT, and Claude Shannon was in room 26340, and I was in room 26340 when I was at MIT, no air conditioning at that time. but because it's an intuitively thinking in terms of entropy and randomness and thinking about mutual information in the digital world, to me, is a nice way to span for traditional statistics to more advanced work. And we know that the entropy definition from the real world and the entropy definition of the digital world are linked. I mean, they are, if you look into the Maxwell daemon, people can tell you this is how much energy it's going to be using and what have you. There's some really breakthrough work that is being done in Japan. So I go to this as a mechanism to understand the interrelationship between data and conclusions and the like. And when you look at it that way, then you can find that there is some interrelationship that can be leveraged. The challenge is how far do you leverage them? And this is where this balance between privacy, utility, and fidelity become very interesting to navigate. Interesting to navigate means no one knows how to do it exactly, of course.
Good. Alain,
All right,
I want
I'm
to.
gonna skip the comment because it would open up a whole long discussion.
You have my email, you have my LinkedIn. I welcome you reaching out that way.
That's a good strategy. I think that would be a good way to carry on any conversation that where there's a need to carry it on. Alain, I want to thank you for joining us today. You've given us a tremendous perspective on market research and the introduction of AI into that work. I hope you come back and join us. We have we have a lot of conversations on AI, and in fact, our next our next meeting is on February 13th.
Okay.
Jenny will be speaking about AI from the perspective of the AI bubble and among other things. So if you're free, I hope you'll come back and join us.
It happens to be my birthday, so I'll see if it's the right level of a celebration. If you
Okay.
want me to come one of these days on the evolution of the work of Wagner and its relationship to latent variable in AI, I'll be glad to. But
Wonderful.
at a later time.
Okay.
Could I
With
make
that,
a
I'll figure it in.
May I make a suggestion as to the next presentation?
Yeah.
What you talk about? Quickly, you mentioned a lot of scientific terms, thermodynamics, entropy, randomness, blah, blah, blah. If you could really tie them with what you're doing, not as word, but the whole analogy that kind of Eddie was talking about, that would be a nice presentation. We'd love to hear that.
That would be a nice presentation, but at that point, I'd be going into the intellectual property of data.
Yeah.
And until we got all the work done and patented and what have you, I don't really want to go into it. So I appreciate the interest. It tells me we're going into the right direction, but that one is in the magic sauce for the moment. Maybe a year from now.
All right. Alain, we'll let you
Thank
get back to work, and
Okay.
everyone else
Thank
can
you.
get back to their calendars
Bye-bye.
and schedules.
Bye.
Thank you so much. Very, very much appreciated.
Sure.
Take care, folks. See you in a
Bye-bye.
couple of weeks.
Thanks very much.